Hello and welcome. I am Olunlade Joshua and I will be taking this tutorial course on liquids in motion. This is the second tutorial in this series, and today we are going to be treating continuity of flow. Now, what is meant by continuity of flow? For continuity of flow in any system of fluid flow, the total amount of fluid entering the system must equal the total amount leaving the system. Now, what does this mean? Take a look at the diagram I have below. According to the definition above, for continuity of flow to exist, the total amount of fluid entering the system here must be equal to the total amount of fluid leaving the system. And we know that our rate of fluid flow is given by discharge quantity Q. Let us call this point A and this is point B. So now QA will be equal to QB then, according to this condition. So for continuity of flow, QA must be equal to QB. In this point A, or at the cross section A, we have the velocity of the fluid VA, and we have the diameter of the fluid. Let us represent that with DA. And at this other point, point B, or cross section B, we have the velocity of the fluid VB and DB, the diameter of that cross section. Remember, this is a steady flow condition. Therefore, continuity of flow can only exist when there is uniform flow or steady flow. It cannot exist when we have unsteady flow or when we have flow that is not regular, that is not uniform. Now, let us go on to solve an example on this. Oil flows through a pipeline in figure 1 below, which contracts from 450 millimeter diameter at A. So diameter at A. Okay, where is the figure? This is the figure, and there are the variables. Now it says that it contracts from 450 millimeter diameter at A. So that means diameter at A, DA, is 450 millimeters to 300 millimeter diameter at B. That means diameter at B, DB, is 300 millimeters. That is, this is DA, this is DB. So the diameter of this cross section is 300 millimeters at the end B, and then forks, one branch being 150 millimeter diameter discharging at C. This is point C. This is the fork that is formed. So it says that it is discharging at a diameter of 150 millimeter. So that means DC, which is the diameter of cross section C, is 150 millimeters. And it says this, and the other branch is 225 millimeter diameter. So DD will be equal to 225 millimeter diameter. Now, if the velocity at A is 1.8 millimeter per second and the velocity at D is 3.6 millimeter per second, meter per second, and this is also meter per second. So velocity at A is 1.8 meter per second. Velocity at B, were we given velocity at B? No, that is actually what we are looking for, velocity at B and C. So velocity at B is unknown, velocity at C is unknown too, and then velocity at D is also, okay, it's not unknown, it's known. We're given in the question right here, 3.6 meter per second. It says what will be the discharge at C and D and their velocities. So we have to find QC, QD, and the velocities VB and VC. Now let us go on to the next slide to. So you would think, how would I solve this question? How would I find the discharge at C and the discharge at D and the velocities at B and C? And this is where thinking comes in. Okay, what do we know? We know that the discharge at A is equal to the discharge at B due to continuity of flow. And we know that the discharge at B was divided into two. One goes to C and one goes to D. So therefore, QC plus QD, that is, in general, we know that discharge at A, QA, is equal to discharge at B, QB, and discharge at B is now equal to QC plus QD. This is because the fluid is not created and it is not destroyed, so it is constant. The flow rate throughout that entire pipe network is constant. So QA is equal to QB and it's equal to QC plus QD. This is very important for solution to the question. So now what were we asked to find? We have to find the discharge at C and the discharge at D, and then we have to also find the velocity at B and the velocity at C. So now let us try to resolve for all the discharges, or all the discharge QA, QB, QC and QD. What is QA? What is QB? What is QC? What is QD? Now we know that discharge QA, or discharge in general, Q, can be given as A, that is area of the cross section, times V, which is the velocity, mean velocity. If you don't understand how this is, please watch the previous video in this series. Now QA will be equal to A, that is area of cross section A, multiplied by VA, that's multiplied by the velocity of that of the fluid at that particular point in time. Now we can resolve this further to be 1/4 pi dA square VA, that is QA, and we can just generally bring out the equations for the rest similarly. QB will also be 1/4 pi dB square VB, and QC will be equal to 1/4 pi dC square VB, and QD will be equal to 1/4 pi DD square VD. Okay, now using our equation, this equation, QA is equal to QB, which is equal to QC plus QD. Let us try to solve and see what we can get. Firstly, let us solve QA is equal to QB. Now we know that QA is what? 1/4 pi dA square VA, and QB is 1/4 pi dB square VB. Some things are common to both sides, like 1/4 and pi, so that can cancel out. So now we have dA square VA is equal to dB square VB. Okay, and in the question we can see that we know dA to be 450 millimeters. We know VA to be 1.8 meters per second. We know DB to be 300 millimeters, but we do not know VB. So solving for VB in this equation now. So we have VB will be equal to dA square VA over dB square, and this is just equal to dA is 450 millimeter, but we cannot use 450 millimeter since we are also dealing with meter and millimeter. We have to convert these millimeters to meters, so that will be divided by 1000, and that is 0.450 square multiplied by VA 1.8 over dB is also in millimeters, so we divide that by 1000 to give us meters, and that is 0.300 meters, and that is square. So we have our final answer VB to be equal to 4.05 meters per second. Exactly, 4.05 meters per second. And we have VB now. Okay, let us see how we can calculate something from the rest. We'll still know that QA is equal to QB, which is equal to QC plus QD. Let's use this to solve for other things that we do not know. Okay, let's rewrite that equation. I'm taking it slow like this so that you understand the concept and how to do problem thinking. How do I solve this? How do I get it? I don't just want to solve it using some steps. I want to take you through it. So now, how do we get another thing? Let's go back to our reference equation. QA is equal to QB, which is equal to QC plus QD. Okay, we've used QA is equal to QB. Now let us try to use QB is equal to QC plus QD. That is the second part or something of that equation. So QB is equal to QC plus QD. We know QB to be 1 over 4 pi dB square VB. We know QC to be 1 over 4 pi dC square VC. And we know QD to be 1 over 4 pi DD square VD. Now, I can see some common things here. 1 over 4 pi, 1 over 4 pi, 1 over 4 pi. That is here, here, and here. So now, let us factorize. 1 over 4 pi into bracket dB square VB will be equal to 1 over 4 pi into bracket DC square VC plus DD square VD. 1 over 4 pi cancels 1 over 4 pi. So now we have dB square VB will now be equal to DC square VC plus DD square VD. Okay, so now what do we do? What do we do from here? We check again. What do we know and what do we not know? Do we know dB? Yes, it is given in the question. dB is 300 millimeters. Do we know VB? Yes, we just found it. VB is 4.05 meters per second. Do we know DC? Yes, it is given in the question. DC is equal to DC is equal to 150 millimeters. Let me write that, 150 millimeters. Do we know VC? Do we know VC? No, it is not given in the question. So VC, we have question mark, it is unknown. Do we know DD? Fortunately, it is given in the question. DD is 225 millimeters. Do we know the last one, VD? Is it given in the question? Let us see. Yes, it is. VD, velocity at D, is 3.6 meters per second. Okay, so now we have only one unknown, only this. That means that we can solve. And I can just collect like times here. So VC will be equal to DB square VB minus DD square VD over DC square. Is that correct? Yes. And this is equal to, let me see if I can manage this space, 0.3 square. Remember, converting this to meters, that will be 300 over 1000, which is 0.3. 0.3. Then VB is what? 4.05 minus DD 0.225 square multiplied by VD 3.6 over 0.150. Wow, I managed the space. Okay, so now imputing this on my calculator, VC will be equal to, that is equal to, oh, I forgot square, 0.150 square, and that is equal to 8.1 meters per second. That is VC. And we see that our equation is clearing up a bit now. So we know what we know now, or what we've calculated. We know VB to be equal to 4.05 meters per second, and VC to be equal to 8.1 meters per second. And we were asked to find also discharge at C, that is QC, and discharge at D, QD. Well, that's not so difficult now, because QC is equal to AC times VC, and we already know VC, and QD is equal to AD times VD. We know both, so now we can just easily solve. Let me get a clean slide. Okay, now let me divide this slide into two. Pardon my writing. Q, discharge at C, QC, will be equal to ACVC, which is just 1 over 4 pi DC VC, that's square. 1 over 4 pi multiplied by 0.15 square, then multiplied by VC, which we just calculated to be 8.1 meters per second, and our answer is that is 0.0177 VC, that is times 8.1, which will now be equal to 0.143 1, and our unit is meter cubed per second. So QC, that is the value of QC, and now QD is equal to ADVD, which is equal to 1 over 4 pi DD VD, that's square, and that is 1 over 4 pi times, we know DD from our equation to be 225 square, times we know VD to be from our question to be 3.6. Oh, did I use 225? I'm sorry, that's 0.225. remember, we're converting to meters. 0.225. don't ever forget to work with the correct units, and that will give us QD, discharge at D, will be equal to 0.143 meter cubed per second. And you can see that these both are almost the same, but that's not the point. We got QD, we got QC, we got our VB and VC, and I hope you now can solve at least this kind of question on liquids in motion. In the next tutorial, we'll be considering the rate of change of momentum of fluids in motion. We will use that to derive the energy equations. Well, see you then. If you have any questions or comments, please ask in the comment section below, and don't forget to subscribe to this channel. I'm Olunlade Joshua, and see you next time.